We have all seen the images. Massive, city-sized motherships casting a dark shadow over our most beloved landmarks. Gleaming fleets of smaller fighters swarming through our skies like angry insects. Searing beams of pure energy slicing through skyscrapers, turning steel and concrete into molten slag. These visions of a sudden, overwhelming alien invasion are deeply ingrained in our collective imagination, nurtured for decades by blockbuster films and thrilling novels. This powerful narrative feeds a primal fear of the unknown, the terrifying possibility that humanity is not the apex predator of the cosmos, and that our reign on this small blue world could end in a flash of light. It is a story that is both terrifying and exhilarating. But as a physicist, I am trained to look beyond the dramatic spectacle and ask a simple question. Does this scenario make sense? Does it align with the fundamental laws of nature that govern everything in our universe, from the smallest subatomic particle to the largest galactic cluster? This essay intends to peel back the layers of Hollywood fiction to explore the scientific realities that would shape any potential encounter with an extraterrestrial intelligence. We will embark on a calm, rational journey, systematically dismantling the most common myths about alien attacks. For each popular myth, we will contrast it with the most likely reality, grounded in the principles of physics, biology, and even economics. This myth versus reality approach is not meant to dismiss our fascination with these stories. Instead, it aims to replace fear with a more nuanced and compelling perspective. Understanding the immense challenges any alien civilization would face just to get here provides a more realistic framework for contemplation. We will examine the constraints of energy, the vastness of interstellar space, the likely motivations of a species capable of such a journey, and the true nature of our own strengths and weaknesses. By separating scientific probability from cinematic fantasy, we can begin to see the story of a potential first contact not as an inevitable apocalypse, but as a far more complex and fascinating puzzle. The goal is to provide a clear, calm, and reasoned perspective on a topic often shrouded in panic and sensationalism. Today is October 21st, 2025, and while our skies remain blessedly free of invading armadas, the questions remain as pertinent as ever. What would an alien invasion really look like? By exploring the science, we can move past the nightmare scenarios that haunt our dreams. We can begin to appreciate the sheer scale of the universe and our place within it, fostering a sense of wonder and intellectual curiosity rather than helpless dread. Let us now begin to unravel the myths, one by one. Okay. Myth. Aliens will possess unimaginably powerful superweapons capable of vaporizing entire cities, or even cracking the planet in half with a single, effortless shot. In our stories, their technology is akin to magic defying known physics. These weapons are often shown as directed energy beams firing continuously with perfect accuracy, rendering defense futile. Absolute technological superiority, our military like throwing stones at a modern battle tank, reinforces helplessness and swift annihilation. Reality. Weapons must obey energy and thermodynamics. Vaporizing a city needs colossal energy. Rivaling thousands of nuclear power plants running for a significant period, aliens would carry that energy across light years or generate it on site. Both are staggering engineering challenges. Directed energy weapons are not magic, subject to atmospheric dissipation, air, dust, water vapor which scatter and weaken beams over distance. Consider the physics of it. A laser powerful enough to slice through a building from orbit would heat the air into a plasma, creating a blooming effect that diffuses the beam, making precise targeting incredibly difficult. Any offensive system also has vulnerabilities, needs cooling systems to manage immense waste heat, focusing mechanisms that can be disrupted, power conduits that can be targeted. Advanced weapons are machinery with points of failure. The idea of a perfect unstoppable weapon is pure fantasy. Reality is messier and constrained. Alien arsenals could be formidable, based on principles we may not yet understand, but it would not be magical. It would have logistical requirements, energy limitations, operational weaknesses. Their weapons would need to be powered, aimed, maintained, cooled, governed by universal physical laws. This doesn't mean we'd stand an equal chance, but effortless planet-wide destruction is far less plausible than the movies suggest. It introduces friction and complexity, moving the scenario from fantasy to science myth. Alien fleets will arrive suddenly and without warning, warping through hyperspace using some form of faster-than-light travel to cross the galaxy in a matter of days or weeks. In this narrative, space is like a neighborhood street. Interstellar travel is as simple as a short drive. This rapid transit idea enables the classic surprise attack scenario. They could appear in our orbit fully formed, ready for battle, catching humanity off guard, denying us time to prepare a coordinated defense. The galaxy becomes a small, accessible place where threats can come from anywhere. Reality. The universe is defined by almost incomprehensible vastness. Distances between stars are the single greatest barrier to interstellar travel. Our nearest stellar neighbor, Proxima Centauri, is over 4 light-years away. Infographic. Travel times to Proxima using current and theoretical spacecraft. Our fastest spacecraft would take approximately 80,000 years to get there. Even advanced civilizations face this tyranny of distance. Einstein's relativity. Nothing with mass can reach or exceed light speed. The energy to push mass to a large fraction of light speed is astronomical. Wormholes, warp drives. Both remain speculative and would require colossal energy. Such energy would likely mean harnessing entire stars. A civilization able to do that would be Type 2 or Type 3 on the Kardashev scale. Their engineering energy signatures would be detectable light-years away. Building and launching a huge invasion fleet would be a monumental, visible undertaking. It would broadcast its preparation across the galaxy like a lighthouse. Telescopes' radio arrays constantly scan the skies. Thermal waste and energy expenditure from such a project would show up as anomalies. Therefore, a surprise attack is one of the least likely scenarios. Arrival is far more likely to be slow and deliberate. We would likely have years, decades, or even centuries of warning. We might first detect their exhaust trail as ships decelerate from relativistic speeds. We might see their primary ship as a faint, moving point of light long before it reached our solar system. Long travel times impose severe logistical constraints on invaders. They would need a self-sustaining, multi-generational vessel, a world ship. Fragile and resource-intensive. Space is not a friendly ocean. It is a hostile vacuum. Myth. Aliens will be inherently malevolent, driven by a primal urge to conquer and destroy. Their goal is simple: to exterminate humanity, steal our resources like water and land, and colonize our planet for themselves. This trope draws on our own history of violent conquest and competition for territory. It projects a human-like, zero-sum worldview, assuming the only way to acquire resources is through force. In these stories, aliens are monstrous locusts, stripping one planet bare, moving on to the next, in a cycle of endless consumption and destruction. Reality. The motivations of an interstellar species are likely far more complex, perhaps even incomprehensible to us, but we can make some logical deductions. An advanced civilization would likely have solved resource problems on a planetary and solar system scale. They'd be masters of asteroid mining, fusion, energy materials, science. Earth's most valuable resource isn't raw materials. Water is abundant in the universe, found in comets, asteroids, moons of gas giants, all far easier to harvest than deep inside a planet's gravity well. So, what would they want? Our planet's complex biosphere is demonstrably rare. Life itself might be the ultimate prize. They might be driven by scientific curiosity, viewing Earth as a biological preserve to be studied, not destroyed. Conflict is inefficient and risky. Why wage war on a feisty, nuclear-armed species on their home turf when you could build habitats in space or terraform a more convenient, uninhabited world like Mars? A truly intelligent species would follow the path of least resistance. Open warfare is rarely that path. They may have no interest in us at all. We could be an anthill in the way of a highway, our destruction incidental, not intentional. Or, optimistically, they've transcended violent conflict, having survived their technological adolescence. They might follow a strict ethical code, a prime directive forbidding interference with developing civilizations. Myth. Our global military forces, fighter jets, tanks, nuclear missiles, could mount a successful defense against an alien invasion. This is the triumphant narrative of human resilience, where our grit and ingenuity allow us to find a weak spot and overcome a technologically superior foe. Movies love to show plucky fighter pilot delivering the decisive blow, clever computer virus disabling the alien mothership. This myth appeals to our sense of pride and belief in our ability to triumph against impossible odds. Reality. In a direct, symmetric confrontation, our current weapons would almost certainly be useless. A civilization that has mastered interstellar travel would possess energy manipulation and material science far beyond our own. Comparing their technology to ours would be like comparing a sharpened stick to a stealth bomber. Their ships' hulls would likely be made of materials that could withstand micrometeoroid impacts at near light speed, making them impervious to our kinetic weapons and explosives. Their computer systems would be so advanced that any attempt to hack them with a computer virus would be laughably simplistic, akin to trying to infect a modern supercomputer with a program written for a 1980s calculator. However, this does not mean humanity would be without options. Our greatest strength would be in an asymmetric fight. Guerrilla warfare, hiding among the civilian population, going underground, are classic tactics of a less powerful force. We could leverage our intimate knowledge of our planet's geography and biosphere. We could potentially use biological weapons, our native microbes, to which the aliens would have no natural immunity, although this would be an incredibly dangerous and unpredictable strategy. The key would be to avoid a direct battle and fight a war of attrition. Ultimately, our best defense would be our intelligence and adaptability. We would not win by shooting down their ships, but by surviving, learning, and understanding. If we could capture even a single piece of their technology, our scientists could begin reverse engineering it. Humanity has proven time and again that it is remarkably innovative under pressure. The fight would not be won in a single glorious battle in the skies. It would be a long, arduous struggle for survival fought in labs, bunkers, and the shadows, with the goal of outlasting and outthinking the enemy, not outgunning them. While advanced tech and military might dominate fiction, the decisive factors would be human. Our ability to cooperate, our scientific infrastructure, our psychological resilience. The first sign wouldn't be a spaceship over New York, an anomalous data point on a radio observatory screen, a strange spectral reading from a space telescope. The first responders wouldn't be soldiers, they'd be scientists, calmly verify, analyze, share the findings globally without causing panic. Global cooperation would be paramount. An alien threat is a threat to all humanity. National borders and political squabbles become meaningless combined resources of every space agency. The full power of our global communications network, the collective brainpower of the scientific community marshaled into a single coordinated effort, the greatest cooperative enterprise in human history. A fractured, panicked world fighting itself would be easily defeated. A united planet is a far more complex and resilient problem. Preparation and education are vital, not anti-alien missile batteries. Invest in STEM education, planetary defense systems that detect asteroids and could spot ships, robust continuity plans for government and essential services. Public education inoculates the populace against fear, misinformation, panic. An informed public understands scientific realities, less prone to hysteria, more likely to follow rational guidance. Clear thinking under pressure is greater than any weapon. Defense begins not on the battlefield, but in classrooms, laboratories, halls of government. Built on scientific literacy, international collaboration, shared sense of planetary identity. An invasion forces the question, who are we competing tribes? A single species sharing a fragile home? How we answer this determines our fate more than tech gaps. Our humanity, in all its complexity, is our last and best defense. Throughout this exploration, we have dismantled the terrifying myths of a Hollywood-style alien invasion and replaced them with the sober and in many ways more fascinating realities imposed by science. The vision of a sudden, overwhelming attack by malevolent beings with magical weapons dissolves under the harsh light of physics. We see that the universe is governed by rules, and these rules apply to everyone. The immense energy required for weaponry, the staggering distances that inhibit travel, the complex calculus of motivation all conspire to make a classic invasion scenario highly improbable. Our fears, while understandable, are largely born from fiction, not fact. The reality is that any encounter with an extraterrestrial intelligence would likely be a slow, complex, and profoundly strange affair. Slow and complex, profoundly strange. It would challenge us intellectually and philosophically far more than it would militarily. We learned that our greatest assets are not our missiles and jets. Our global scientific community, our capacity for cooperation, our ability to learn and adapt. These are the tools that will truly shape our future, whether we face a threat from the stars or continue to solve our problems here on Earth. The prospect of contact forces us to look in the mirror and encourages us to become a more united and intelligent species. This does not mean we should be naive or complacent. A healthy sense of caution is always wise when facing the unknown, but we should let our primary response be one of wonder, not fear. The search for extraterrestrial intelligence, CT, is one of the most profound scientific quests ever undertaken. It is an exploration into our own place in the cosmos. Every radio telescope that scans the night sky is a testament to our hope and our insatiable curiosity. This is the spirit we must cultivate. The universe is vast and full of wonders. The possibility of life elsewhere should inspire us, not terrify us. So, let us move forward not by building walls, but by building bigger telescopes. Let us invest not in weapons of war, but in the tools of education and discovery. The story of humanity is a story of overcoming challenges by expanding our knowledge and working together. Keep asking questions, embrace reason, continue looking up at the stars. Not with dread of what might come down, but with excitement for what we might one day find. The silent, starry night is not an empty threat. It is an open invitation to learn.